in this tutorial, I'm going to showcase to you how we read data into pumas and make pumas parse a data set as a population. So for now, I'm going to be using a pumas package, of course. And we also have a package called pharma datasets, which is in the ecosystem of pumas. And this package has several other datasets that are ready for the most common workflows in PKPD model. And I call those datasets with the dataset function. So let's take a look at the dataset. IV single dose 3. That's this dataset here. As you can see, it's a no-man formatted dataset. We do have the standard columns like ID, time, DD, like that's your observations, amount, EVID, compartment, rate, and dose group, which is a covariate. Now, to read this data into pumas, we are going to be using the read pumas function. And if we take a look at the docstring, the read pumas function, it import nmtrain format the beta set, then it type it down here, which is easier. So it imports nmtrain format the data, and it also returns to us a population. As you can see from the function signature, we do have several covariates, but several keyword arguments, but only one position argument, which is a data frame. So this function will read a data frame. And these keyword arguments, they signal pumas to look for certain column types in your data frame. So for example, the ID column should be the column all lowercase ID. Time has a default value of time. And observation is by default a factor, a list of column names, because pumas can handle more than one dependent variable. And by default, it's just a symbol, a vector of symbol, which length 1 with only one column name dv. And we also have covariates here. By default, it's an empty list of column names. So let's take a look again into our data frame. Now, as you can see, those column names, they're pretty much the same as the keyword argument. So we don't need to override anything. We just need to pass the position argument, which is the data frame. In our case, the df variable. When I do this, pumas parses the data set and returns a population. And here I can see that we have 120 subjects, and we have only one observation, which is the dv variable. And this is pretty much what we get from this data set. Now that was, suppose we have a beta frame which has different column names, not that the default ones specified by the read pumas function. How do we handle that? Now, I'm going to be calling this columns pop, read pumas function again, and the position argument is the columns df. Now I need to specify some keyword arguments. So if you take a look at the pumas, I need to override almost all of those because they are not the default argument. I need to pass new arguments to the keyword arguments in the read pumas function. So let's start. Let me see. First of all, I have the ID column is ID all caps. Time column is time. After dosing, all caps. My observations is the most important. Observations is a list or a vector of column names. So by default, in our dataset is conc, and I only have one. If I had more, I could add more here. Also, my amount is all caps amount. My compartment is all caps compartment. And my EVID column is all caps EVID. And my compartment column, I already did that one. I think I got most of those. Amount, yeah. As you can see, pumas populations, it's not sensitive to, it's sensitive to lower and uppercase. So you've had column names that are lowercase or uppercase or a mix of those like the EGFR column, you have to specify it back as it is. So that is different in Pumas. Now, as you can see, we also have covariates here. And covariates by default, it's just an empty vector. We have all of those columns here, age, weight, urine creatinine levels, Ismail, and the EGFR column. They are all covariates. Though I would also to import those in my population. So observations, not observations, covariates equals, now I pass in a list, a vector of column names as symbols. So weight, SCR, Ismail, EGFR. I think that's it. If I haven't typed anything wrong here, Pumas shall parse this data frame and get all of the important column names by getting the arguments from those keyword arguments that I specify, and let's run this block of code. And as you can see, we do have Pumas has parsed correctly our non-man data set. We have 100 subjects. These are our covariates, and these are our observations or dependent variables. And this is how we parse it. Now, also, Pumas supports other. This is other non-man column names. So, for example, this is a non-man format data set, which we have the MPV. This is the DSIN view. As you can see, this our div v here, which is hist here. Whenever it is a dosing event, so if VID is equals 1, or we do have an amount and a compartment, we have this MPV variable. Now, Pumas, it can also read this. So let's create a pop. Let's add a new line, create a pop, MBG here. And this is read Pumas. The only position argument is our MBV yes, and we do need to specify and override several keyword dynamics. So time is all caps time. ID is a column called CID, all caps. We have our observations is hist. We also have amount equals amount. We also have compartment equals compartment. Also rate equals all caps rate. And NDD equals NDD. Now let's see if this works. As you can see, Pumas gave a warning because our dataset doesn't have an EGID column, and it's just warning us that it's having 1 for dosing rows and 0 for other in the EVID column. And if this isn't the case, we definitely need to add an EVID column in our dataset. And as you can see, we have 20 subjects, and our observations are in the hist, and this population is ready to be used in a PKPD workflow. And that's how we import non-man formatted data sets into Pumas. It's really easy. Sometimes, if you are lucky, you don't have to override any of the keyword arguments. Otherwise, you do have to override and specify your custom problem names for those keyword arguments.